A line drawn through the center of a circle to bisect a chord is perpendicular to the chord. I would like you guys to pause, think over what does this mean. Okay, I'll explain with an example now. A line drawn through the center of a circle. Okay, I have a line drawn through the center of the circle. Here, a line. Okay, to bisect a chord. So I have a chord, and this happens to bisect this. That is, if this is AB, and that's M. This is of length, say, how much do you guys want it to be? Okay, 18 centimeter. I'm hearing few people telling 18, so I'm going to take that. So we have this to be of 9 centimeter and this to be of 9 centimeter. So this particular line is bisecting this chord, right? It's dividing it into two equal parts. This is given. Let's read the statement again. Line drawn through the center, so it's passing through the center of a circle to bisect a chord is perpendicular. The conclusion is, then we can conclude that this is perpendicular. Okay, so basically any line from the center drawn to cut the chord into two equal half will be perpendicular. So this is your theorem. Okay, so let's talk about how to prove this. Can you guys think about it? It's not that hard. So let me draw the diagram for you guys first. So let's consider a chord. That's your center. That's a line which bisects this. Say this is AB and that's M. AM is equal to MB. So this is your diagram. Now I would like you guys to think over. Okay, so it's quite simple. All we have to do is prove that these two triangles are congruent. And we are done. So now let's begin by writing down, describing the diagram. Let's consider a circle with center O. AB be a chord. Let OM bisect AB. This implies AM is equal to MB. Right? Then what else? That's it. So we need to prove AB is perpendicular to MB. And now the proof. Consider triangle OAM and triangle OBM. So OM is common. Then we have AM is equal to MB. This is in given. And we have OA is equal to OB. And this is your radius, radii. Okay. So with this, we can tell that by what congruency? Yes, side, side, side. Triangle OAM is congruent to triangle OBM. But how can we prove that, they are perpendicular? We just prove that they are congruent. I told it will help. But how can we tell that this is 90 degree now? Any idea? Well, since these two triangles are congruent, these two angles have to be equal to each other. Okay. If they are equal, so what? They will add up to 180 degree, and so each has to be 90 degree. So let me show you guys that. This implies angle OMA is equal to angle OMB CPCT. Okay, and we have OMA angle plus angle OMB, which is equal to 180. Reason? What is the reason? Because they are linear pair, they stand on a straight line. Because they are linear pair, they add up to 180 degree, and therefore 2 times of angle OMA is equal to 180 degree divided by 2 both the sides. And why did I write 2 times? Because of equation 1 from 1, that these two angles are same. So you can do this, and we are dividing with 2, so OMA is equal to 90 degree, and this implies OM is perpendicular to AB. Hence we have proved what is required, right? So this is your write-up, and that's your theorem.